Okay, here's a question I often get, so I'll try to address it. And the question is, what is a logarithm? And maybe we'll have a couple follow-up questions to that, because the questions really are a lot more interesting than the answers. So I'll leave that blank for now. We'll come back and maybe you can fill that in. What is a logarithm? So to answer a question with a question, I will pose to you, what is an exponent? And hopefully you have some answer for that. Because if you don't, the bad news is, if you don't know what an exponent is, you're not really going to understand what a logarithm is. So I'll presume you know what an exponent is. The good news, however, is if you do understand what an exponent is, then you will understand what a logarithm is. Let me prove it to you. 2 to the third power, for example, you should know, of course, is 2. 4, 8. 2 times 2 times 2, which is 8. Easy, yeah? Maybe a little harder. How about 5 raised to the fourth power? That is, hopefully you're able to do that without the calculator. 625, maybe needed a paper and pencil. I knew it was coming, so I had a chance to think about it ahead of time. 10, this is exponents. This is stuff that you should be familiar with. 10 raised to the sixth power, of course, is 10 times 10 times 10 times 10 10 times 10 times 10, or 100,000. No. One more. 1 million. Can't count. If you can't count, don't worry. Logarithms are still going to be easy. 3 to the fifth power. That is 243. A little harder, huh? Here's a much harder one. What if we wanted to take 10 and raise it to the 2.3 power? Can you even do that? Well, sure. What's 10 to the second power? That's 100. So it's going to be something a little bit more than 100. No, probably less than 1,000. That's not really precise. If you want it more precise, you might go get a calculator for that one. So I'm going to leave that one blank. It's kind of a problem. Sometimes exponents are very easy to calculate. Sometimes they're a little harder to calculate, and we want to get a calculator for it. Same thing with logarithms, as you'll see in a second. So let me show you what a logarithm is. A logarithm really is nothing other than another way to write an exponent. So for example, on this one right here, what we're saying is 2 multiplied 3 times. In exponents, we call this the base. So over here in a logarithm, the way we write this is log, the base is 2. So we say log base 2 of 8 is 3. And this is just merely notation. And what we mean by this notation is, if you take 2, you ask how many times you multiply it by itself to get 8. And the answer, of course, is 3. Same as exponents. Let's try a couple more of those. I think you'll get the hang of it. In this one, the base, of course, is 5. So we say log base 5 of 625 equals 4. Starting to see this pattern, hopefully. But really more important than the pattern is the idea. So here we have log base 10, because the base is 10, of, do I have the right number? I don't know if I have the right number. I'll fix this later if I'm counting this wrong. Of 1,000,000. I'll blur together on the page. Log base 10 of this number, that is to say 10 raised to the 6th power, is 100 million. Or a million. And of course, this one would be log, the base is 3, of 243, and that's going to equal 5. So that we can always go back and forth from something in an exponential statement to a logarithmic statement. That is to say, we can write the same information in a different way. We don't always have to start with the exponent. So what I'm going to try now is we're going to skip this one for a second, although you can pause the video and try it. It's fun. We'll come back to it. Suppose I told you that the log suppose I tried that again. I said that the log base 2 of 64 was equal to something. And what you're doing with a logarithm is saying, okay, 2 raised to some power is 64. That is to say, a logarithm is another way to think of exponents. So 2, 4, 8, 16, 32, 65, 6. So log base 2 of 64 is 6. How do I know that? I know that because 2 raised to the 6th power is equal to 64. I'm more comfortable with exponents. I've known them longer, but really they're two sides of the same coin. Let's try one more. What about the log base 4 of 16? Again, you're taking, probably easier to think of it in exponents, you're taking 4, you're raising it to some exponent to get 16. 4 raised to something is 16, which of course you know to be 2. So that the log base 4 of 16 is equal to 2. Hopefully that makes some sense. Up here, what do we do with this thing here? Suppose we knew this number, 10 raised to the 2.3. I'm just going to guess. I'm going to just say it's like 150. I didn't go get a calculator to do that. I just guessed. So 10 raised to the 2.3 is, say it's 150. What would that mean over here? Well, that would mean that the log base 10 of 150 was equal to 2.3. Now, I'll say it again. This probably isn't right, but if this is right, then this is right. Again, there's your answer again. You have to write it in yourself. Oops. The answer. You have to write it in yourself. A logarithm is just another way to write an exponent. Nothing more, nothing less. A couple follow-up questions, although really you ought to have your own follow-up questions. I'll suggest a couple, because these are pretty common questions. Often this first one is asked in exasperation and frustration, and it is, who uses these? See, notice the exclamation point as well as the question mark. I'm not going to answer that for you right now, but what I would say is go back up to exponents and ask the same question. Who uses exponents? Probably the same people use logarithms as well. That's one question. Another question that often, and you should generate your own questions. That's really what the game's all about. Another good question, however, is why do we need 2 ways to represent this information? We're just doing the same thing here. 2 to the 3rd power is 8. Why do we need a second way to represent that? Anyway, if you have some other questions, let me know. Maybe I'll answer them. Maybe I'll give you follow-up questions.